So now we're going to move on to look at some uses of the gradient function and how we can apply it to questions involving curves. So once we've got the gradient function, which we know that gives us the gradient of the curve at each value of x, so if we have a look at this particular example, what we can then do is use the gradient function to find the gradient at certain points on the curve. So in this question, we're told the equation of the curve. So in order to find the gradient at these points, the first thing we're going to need to do is to differentiate to find the gradient function. So that will give me 2 times a half, which is 1, reduce the power by 1, plus 4. And at this point, the first point 0 minus 3, so at x equals 0, we don't actually need to use the minus 3. dy by dx, substituting into x plus 4 will just be 4. And at x equals 2, dy by dx will be 2 plus 4, so at this point the gradient is equal to 6. In the second part of this question, we're asked to find the coordinates of the point where the gradient is 0. So if the gradient is 0, well, that tells me that dy by dx is 0. So I know that dy by dx is x plus 4, so let's put x plus 4 equal to 0. So that tells me x equals minus 4, that's the point where the gradient is equal to 0, but because it's asked for the coordinates, I need to substitute back into the equation of my curve to find the corresponding y coordinate. So we have y equals a half times minus 4 squared plus 4 times by minus 4, and then take away 3. So remember, minus 4 squared is plus 16, half of that is 8, minus 16 minus 3, which gives me minus 11. So the coordinates of the point where the gradient is 0 is the point minus 4, minus 11. So now I would like you to find the differentiation gradients worksheet on Teams. There'll be some questions on the worksheet, and it will also point you to some questions in exercise 8b of the Further Maths textbook.